Thank you, Dina, for this presentation. It was really interesting to see both presentations today. Would you like to comment something, okay, Dano?
Well, they're very different presentation because originally it was Spectrum, but quite interesting. I think we learned from Spectrum presentation from Ramon. The point for operator, as I said, is how to use this spectrum in a reliable way, and this is something that is more regulatory than technical, I would say. But we see that in the future, from technical point of view, we will be able to use that. The second presentation is very good, very interesting. My question would be, how long it will take to bring that to our networks, to our systems? The point of having the video codec and the channel codification in the same step is clever, but this will mean that we will have to have the cellular system adapted to this. Okay, so it will take a time, but of course it's a smart solution. In fact, when you are transmitting voice in a cellular system, in a digital cellular system, you adapt the codec of the voice for this being transmitted in an easier way. My question would be, is it possible to do this in 2 steps? I mean, knowing the channel codification you will have later, adapting your video codec for having a similar effect to this?
So this is actually a very interesting question. So, actually, you mentioned one thing that I want to first, before answering the question, go back to. You mentioned audio. So similarly, audio is very similar to video in nature. Basically, audio, the only difference is that audio is much smaller in terms of bitrate, so we don't care about blotting audio with adding an excessive amount of redundancy. But actually, there was a case in New York City where the firefighters in New York City moved from digital audio to analog, moved from analog audio to digital audio so that they can have more efficient transmission. Then they went back to analog audio because to them, it really means a lot to be able to hear something as opposed to hear nothing when the channel is bad. So this is the same, audio is exactly the same thing. And actually, even despite the fact that audio is like low bitrate, in the extreme scenarios, you see that you want to do this kind of behavior, the smooth degradation. So the other thing is, like, can we do it in stages? So I think, yeah, you can do it in stages. You're not going to get the full performance benefits, obviously. But if you think about the key idea underneath it, is really what you want is to maintain, to have an equal error correction, basically, and to your video. You should not spend as much. Video, basically, in nature has least significant bit and has most significant bit. You don't want to spend equal energy on these different bits in nature. So what you want is, to some extent, achieve this performance of putting less energy, putting less resources on the least significant bit and more on the most significant bit. You can try to, this mechanism achieves it very naturally because it directly maps the least significant bit in the video to the least significant bit on the channel. But you can try to achieve it gradually by just like dividing into a few, putting unequal error protection on these like different style of bits and achieve some of these benefits, but not all.
Another question could be practical implementation of both. I mean, although there are different solutions, when do we think that we will use spectrum dynamically, both internally or with white spaces? And second question, when this could be available for our system? So.
Well, as white spaces, I already said that I think the technology will be ready probably in the window time span of 2020, because even nowadays there are already technology available. For example, I read from Microsoft just as they have a platform, and they've been doing, I would say, tests, and the issue is just to refine all the minor problems, but it's not a problem as a whole. It's my view. For example, we have to, of course, what kind, in order to allocate a white space channel to a user, we need for sure some databases, some precise databases. They have used a kind of NISA databases of the terrain. Also, some propagation modeling. Finally, some more or less complex propagation model should be necessary that puts some computation effort on top of that. That are, I would say, not minor things, but so that's a technical question that can be solved. Yeah, it's not, I don't think it's a big problem. The problem, I agree with you, from my point of view, and on this kind of white stress came from the regulators, in my opinion, that I'm not so sure that European regulators are too conservative, have been too conservative over the 100 years ago, so I'm not thinking they're going to change in 10 days. 10 days or in 10 years.
10 years. And in the cognitive radio for using in our own system?
I think the cognitive radio is what is cognitive radio? Cognitive radio at the end is a lot of things. Maybe DECT, even Wi-Fi is a kind of a very initial cognitive radio in some way. So I think that is more easy to because it depends just on the industry, the technology, on the, for example, what I mentioned before, it's just put in a femto, maybe some kind of algorithm that build the manufacturers just to do that. I don't think it's a big problem. Or even it's just coming back to the more precisely to the case studies I have the opportunity to work on. Today is a big problem, right? In Telefonica, I know from people from Telefonica, simple issues just to the setting of the parameters. It's not technically high technical or high technology, but you have to put that with less OPEX, and you need to put in a very, very, I would say, non-automatic way. So that's also, that kind of procedures can help, I think, in a not a difficult way. Of course, you have to improve the details and all this stuff, but I think it's probably, in my opinion, even some cognitive, I would say, technique has been, I mentioned have been issued in another presentation. But I think cognitive radio is really not up to the regulators, but up to the manufacturers and operators in this environment.
From your side, when do you think that this could be used? I mean, the solution you propose could be used in our networks.
So, I'm not sure. Obviously, it would take some time, but I think particularly for cellular networks, you guys are slow. I mean, slow in the sense that you invest a lot in the infrastructure, and as a result, you naturally cannot move very quickly. So it is important for cellular companies not to look at the solution that is going to be happening in 2 years, because in 2 years, you're not going to change your infrastructure, but to have a longer vision and look at solutions that are going to be available or possible in like 5 years, some like 10 years time frame. Otherwise, I mean, that's just the nature of the development and how fast you can change the infrastructure. So this is one thing. The other thing is that, so we've been talking about white spaces, TV white spaces, but one of the other bands that people are eyeing now are the public safety frequencies. And on those frequencies, so I just mentioned this issue about the firefighters in New York. I mean, basically, the public safety, for public safety, video and audio application are really important. And not just video, like they are not going to just, firefighters don't use video for entertainment. They actually want to use it for emergency situation and critical missions. So in that sense, basically, maybe these new public safety frequencies can be one way to develop these more innovative and different mechanisms and see them like happening. So one way one can think of it is that if the public safety frequencies are going to also be used for commercial communication, then maybe what the provider has to do is to provide an infrastructure that allows the public safety usage to be very resilient, very reliant, and kind of like they are paying a cost by introducing innovation of this sort, but at the same time getting a return which they can use much more of frequencies.
So following on this, what would you need to implement this in an operator? What would be the changes that you have to do? You have to develop an application for the cell phones. You have to change something in the network. What are the changes that you would need to have this as a real product?
So to be able to use these things, there are some changes that are unfortunately going to happen on both sides. Basically, it's like when you are talking about code, like coding and decoding, basically, they both have to happen on both sides. Now, the good news, actually, there is a lot of reuse of the same components. Like DCT, for example, is used in MPEG anyway, but we are using it differently. These channels are OFDM channels, so that's again, reuse of the same components. But there have to be some changes, which are like some that have to do with traditional error correcting code, which does not understand differences between bits and operates on bits as opposed to real numbers. So these are the main changes that should happen, but unfortunately, they have to happen on both sides. Now, one thing is whether there are companies that actually own both sides. Like I know, for example, you guys get some of your equipment from Huawei, and Huawei now wants to also get into the tablet business. So some companies might see this as a means for differentiating themselves in the tablet domain, where it's very hard, it's a very growing market, but it's very hard to find the differentiation. At the same time, you need a company that has surplus so that they can take a hit at the beginning, so that they are giving you the cell towers for the base station for almost zero, like no cost. They are clearly getting a hit on that, hoping to get more, to capture the market more in the future. So different companies have different strategy, and these business strategy may align with doing something like this.
But the problem of changing the channel coding, you have to change for everybody, for nobody. I mean, it will be tough if we have some video transmitted through Huawei base station, in this case, only being able to be received in Huawei tablets. This will not work. It will be easier if we have not to touch the channel. This is the reason why I asked for the 2 stages. If we do in 2 stages, companies that are doing video optimization, for instance, can do this pre-coding that is suitable, maybe not with the complete benefit of this, but this will be easier. This was the reason of my first question. But changing the coding will take a lot of time, because you have to change all the devices.
So I'm not sure this is really, I mean, you can think of it similarly to how you want to offload some of the cellular service to the Wi-Fi. I mean, you have to discover that the device has a Wi-Fi, it's Wi-Fi capable. So similarly, you might start by saying, okay, let me use the standard coding and to the system, and then you discover, oh, but by the way, this tablet is enabled to receive a different video, so can't think of it as like offloading to this other radio.
I don't know if there's any comment from the audience. Can we have the microphone over there?
So basically, I've got the impression that you want to disrupt the last mile, and I'm afraid that you are breaking a little bit the end-to-end paradigm that has been in internet successful. So it's a polemist question. So are you not afraid about the impact of this in terms of, I don't know, I mean, the whole philosophy will be a little bit changed? Thanks.
So that's a very interesting question, because like as a professor, I actually teach the end-to-end paradigm. But I think it depends on how you understand it. The end-to-end paradigm was saying that you don't do inside the network what you could do more efficiently at the end. But it says, actually, if you read the paper, it says explicitly this doesn't mean that you shouldn't do anything. It's a lower layer. You should do it if it's beneficial. So, so I don't think it breaks the end-to-end paradigm. I think actually what we really need, so traditionally we had an end-to-end paradigm that was suitable for the old internet, wired networks, and for different type of sources. Like the last 20 years, the biggest data consumers were software patches on the internet. So we have a model of the end-to-end that is stuck in our head that is really based on internet and with software patches and these elephant flows, while now the new model is like wireless mobile devices with sources really that are audio and video and sensors. So it's really reshaping the end-to-end concept and maintaining the flexibility of the end-to-end concept and basically rethinking what are the boundaries, what is the API between the layers.
I think we should break the paradigm. I mean, we have been talking about that the network has to be application aware. There are people that are saying that even a scheduler has to be application aware. Well, this is another step. There is the channel coding has to be application aware and is efficient, I would say. Any further question? Yes, we have.
Thank you. Robert Joyce, Telephonic UK. More a question on spectrum. TV now has 3 delivery mechanisms, cable, satellite, and DTT. Isn't it time we switched off the DTT?
That's my very personal view, the television digital, or digital television, really could be, I would say, conveyed by other means that such precious spectrum band that we are using nowadays. But again, it's not a technical issue, it's a regulatory issue, even a political issue in that respect. So I may agree with you, but I'm afraid that is no way to do in another manner.
Yeah, we seem to be doing a lot of work, on cognitive radios. I think, the amount of effort that's going in there from a regulation point of view, a technical point of view, it would be a lot simpler, I think, and the other thing you mentioned as well about frequency reuse in digital TV, we were promised multicast when DVB was first announced. Surely we can push a lot of the DTT to be a single frequency network just as we use our spectrum efficiently. So I think there's a lot of effort that should be put on that DTT band because it's, as you said, a very valuable piece of spectrum that could be more efficiently used, especially in the home, as you say, at low frequency for going through walls. So it's just a thought, and I guess I get a bit of sick of seeing such bandwidth wasted with bid-up TV sometimes when I'm flicking through my channels. So I wish it could be used to better effect.
I think you're right, and I fully agree with that. But there are people, remember yesterday in this same forum, there are people that say that broadcaster has more value than cellular, so spectrum is there because they create more value. I completely disagree with that, but this is the level of opinion. Unfortunately, regulator usually thinks that broadcaster has more value because of their political value mainly. We have one more question.
David Barker, Quintel Technology. Just building on the all the presentations, in fact. There was an interesting British telecom research project which looked at 700 megahertz, which is actually the TV spectrum in the UK. But if you look at London, for example, the TV guys don't use 700. So the idea was to use a 700 femtocell. It covers the street rather than just the house because of the favorable propagation. You connect that to the FON network. The idea is other people can use it. We saw FON yesterday, the concept of FON. But it's a perfect white space application. And I use something like the US frequency band plan, which means I've got an ecosystem. of base stations and hardware and handsets in the future. But it's laterally thinking about the femto problem, the white space problem, and the capacity problem. So that's just an interesting note to wrap up those three topics. So the idea is 700 megahertz, US or India style band plan, but here in Europe. So it's sort of using interleaved spectrum on a geographic basis. And you wouldn't need cognitive radio. You know where the TV channels are and where you can't use certain frequencies. So it's not a, if I go out of the area, I'll fall back to the 800 network. But when I'm in London, for example, I've got double the double low band spectrum. So it's an idea that I know has been discussed, at least within Ofcom, but it's an interesting thing to take the themes of this conference forward.
I think that from technical point of view, it's feasible. This is what we heard from Ramon. The only thing you have to know is where it's transmitting and where not. So feasible is feasible. I fully agree with you. Okay. I think it's time to finish and close this session and doing a fast wrap-up for going to have lunch. First of all, I would like to thank everybody here, both the audience, but especially the speakers for being here. For Telefónica has been quite useful, this session. This open your eyes. Sometimes thinking about what will happen in long-term view, from technology point of view, it is quite healthy and quite interesting. And there are many things that has opened at least my eyes, and I think my colleagues as well. I mean, we have been talking about device-to-device, relays, millimeters band that we didn't talk that much before. Small cells, we saw that from a long time ago, but I think that we have discussing about small cell and how to be feasible. Spectrum is clear, the need of more spectrum and the possibilities of using this spectrum in a different way. So the conclusion is clear. Technically we can use, and let's hope that our regulator will allow us to do that. From the discussion about quality of experience, there are several subjects that has been very interesting, but there one key thing that is discussion that usually we have in the company is to what level we have to distribute the intelligence in our network. This is key, and this will be key for the future. And I think you have helped us to think about that. We have been talking about new architecture. The first talk of the summit, we have a new architecture proposal, and there has been another proposal for new architecture in the radio. They are quite interesting, and I think we have to think about that. In summary, I mean, useful session for us, many things to think about, and I would like to thank all the speakers. So thank you for this. I hope that we'll keep in touch. We will see in another network summit that hopefully we'll have next year. From practical point of view, we will have all the presentation for the speaker in attendance if you want to have that. And now we'll have lunch outside. Dina, you want to say something? Oh, for sure. I forgot. Sorry for that.
No problem. I dragged them inside, while they were taking care of lunch. So they have arranged for everything that you got to experience in the past 2 days. Stand up, you guys. I have 10 bucks. And they have been the people that you contacted, throughout your travel arrangements and everything. So we owe you everything. Thank you. That was it.
Thank you.
And lunch is outside.
Thank you very much. Let's go for lunch. Thank you, everybody.